Okay, so guys, now in this video we have to find the derivative of inverse hyperbolic function. So the derivative of sine hyperbolic inverse x is 1 divided by square root of 1 plus x square. Then the derivative of cos hyperbolic inverse x is 1 divided by square root of x square minus 1. Derivative of tan hyperbolic inverse x is 1 divided by 1 minus x square. Derivative of cosec inverse hyperbolic inverse x is negative x mod root of 1 plus x square. So what is the purpose of mod? It actually converts a negative number into a positive number, okay? And it leaves the positive number as it is. So when you're having a negative, for example, any number, variable, whatever, if you add a mod to it, it will become positive, okay? So that's the purpose of mod. And then the derivative of sec inverse hyperbolic x is negative 1 divided by x square root of 1 minus x square, and the coth hyperbolic inverse x is the same as tangent hyperbolic inverse x. So you can access the PDF of this sheet in the description of this video. So now let's continue with some practice problem. Okay, so first of all we have to find the derivative of tangent hyperbolic inverse sin x. Okay, so sin x is actually my x over here. Okay, if we compare it to the actual equation, our x is sin x. Okay, so let's just apply the differentials on both sides of the equation. D by dx. So first of all, if this is my x, we can rewrite this term by replacing the x with sin x. 1 divided by 1 minus, instead of writing x, we will write sin x squared multiplied by the derivative of the angle. What is the angle? This thing right over here is my angle, so the derivative of sin x. Okay, 1 divided by 1 minus sin squared x multiplied by the derivative of sin x is cos x. 1 divided by, now this is actually a property that cos square x plus sin square x is actually equal to 1. So if we just subtract sin square x by moving it to the opposite side of the equation, we will have cos square x would be equal to 1 minus sin square x. Okay, this is actually equal to cos square x, right? And we have 1 minus sin square x, so we can write cos square x multiplied by cos x. So the second power would be cancelled by this term right over here, and we are left with 1 divided by cos x. So this is the final derivative. Now we have to find the derivative of sine hyperbolic inverse 4x. Okay, so this thing right over here is my x. Now the derivative of sine hyperbolic inverse x, so instead of writing x, we will replace this thing with 4x. So let's just apply the differentials on both sides of the equation. We will just write 1 divided by square root of 1 plus, instead of writing x, we will write 4x squared multiplied by the derivative of the angle. This thing right over here is my angle, so the derivative of 4x. You can call it an angle, or you can also call it the function of sine hyperbolic inverse. Okay, so the derivative of the function of the sine hyperbolic inverse. So 1 divided by 1 plus, you can write 16x squared, okay, multiplied by the derivative of 4x would be 4, because the x's will be cancelled and we are left with a 4 because it is a constant. The derivative won't have any effect on it. So this is the final derivative, 4 divided by 1 plus 16x squared. Now we have to find the derivative of sine hyperbolic inverse x cube. So let's just apply the differentials on both sides of the equation. Now we just studied right over here that the derivative of sine hyperbolic inverse x is root of 1 plus x square. So root of 1 plus, instead of writing x, we will write x cube, and the whole square will actually be as it is, as it was in the formula, original formula, multiplied by the derivative of the angle, so it is x cube. These exponents will be multiplied, so 3 multiplied by 2 is 6 multiplied by the derivative of x cube. So the power will be separated, the function as it is, then the power minus 1, 3 minus 1 is 2. So the final derivative is 3x squared divided by square root of 1 plus x6. So let's just apply the differentials on both sides of the equation, and we have to find the derivative of cos hyperbolic inverse x cube. Okay, so we just, in the previous part, we just studied the derivative of sine hyperbolic inverse x cube. So now it is the same thing. So 1 divided by, instead of writing x, we will write x cube. Okay, so x cube squared minus 1 multiplied by the derivative of the angle. What is the angle? X cube is the angle, so x cube. 1 divided by 3 multiplied by 2 is 6 minus 1 multiplied by the derivative of x cube, we just studied, it is 3x square. So we can write 3x square divided by square root of x6 minus 1. This is the final derivative. So we have to find the derivative of sine hyperbolic inverse x divided by 2. So the derivative of sine hyperbolic inverse x is 1 divided by square root of 1 plus x square. So we can just simply apply the differentials on both sides of the equation. So instead of writing x in this equation, we will write x divided by 2, because that is the angle given to us. So 1 divided by square root of 1 plus, instead of writing x, we will write x divided by 2 whole squared multiplied by the derivative of the angle, d by dx, 1 divided by 2x. So we can actually write x divided by 2 as 1 divided by 2 multiplied by x. 1 divided by square root of 1 plus x squared divided by 4. Okay, so the square will be multiplied by all of these terms present inside the bracket, multiplied by 1 divided by 2 is a constant, dx will be cancelled and we are left with a 1. Okay, so I hope you understand the derivative of 1 divided by 2x. Let me just clear over here. This thing is a constant, would be separated. We are left with d by dx x. Okay, so it would be 1 divided by 2. This thing right over here. 1 divided by square root of, we can take an LCM right over here. So 4 plus x square, okay, because 1 is having already a 1 by default in the denominator. So the 4 will be multiplied by 1 and we are left with a 4. So 4 plus x square multiplied by 1 divided by 2. Okay, so the 4 is actually, you know, a square of 2. So we can write it 2 square. So 1 divided by square root of 4 plus x square divided by 2 square multiplied by 1 divided by 2. So you can see that this square can be cancelled by this square root right over here, so the denominator will just come out. So we are left with 1 divided by square root of 4 plus x square divided by 2. Okay, so the square root was just removed from the 2 in the denominator. Now the 2 is actually a denominator of the denominator. It is something like x divided by a divided by m. This m is 2. So we can write x multiplied by m divided by a. Okay, so the denominator of the denominator becomes the numerator. Okay, so we can write, so we can move this 2 towards the numerator. So 2 multiplied by 1 divided by root of 4 plus x square multiplied by 1 divided by 2. So this 2 will be cancelled and we are left with 1 divided by square root of 4 plus x square. This is the final derivative. Okay, so now we have to find the derivative of y is equal to tan hyperbolic inverse x power 1 by 2. So the derivative of tan hyperbolic inverse x was actually 1 divided by 1 minus x square. So let's just apply the differential on both sides of the equation. So the derivative of tan hyperbolic inverse x is 1 divided by 1 minus x square. So 1 divided by 1 minus, instead of writing x, I will write x power 1 divided by 2, and this square is actually by default present in the formula, multiplied by the derivative of the angle. What is the angle? It is this thing right over here. So the derivative of x power 1 by 2, 1 divided by 1 minus x. This exponent of x will be multiplied by this exponent 2 of the formula. So 1 divided by 2 multiplied by 2 multiplied by the derivative of x power 1 by 2. So 1 by 2 would be separated, the function as it is, power minus 1. So 1 by 2 minus 1 is actually negative 1 by 2. 1 divided by 1 minus, these 2's will be cancelled and we are left with x multiplied by 1 divided by, so we can reciprocate it, so it would become positive, and the x power 1 by 2 is actually equal to square root x. So we can write it like this. So we are left with 1 divided by 2 square root x 1 minus x. Okay, so these terms are actually being multiplied, so we can just write them collectively. Okay, so now we have to find the derivative of y is equal to sine hyperbolic inverse ax plus b. Now there are two methods of solving this question. One method is the one by which we have been solving all of these questions previously. Okay, that's the most simplest method by which you can solve for this question. There is another method by which we are actually utilizing the chain rule to find the derivative, and I will show both of them to you. First of all, let's just use the first method, the traditional method. Let's just apply the differential on both sides of the equation, d by dx. So this thing right over here is my x. So instead of writing x, we have to write ax plus b. So 1 divided by square root of 1 plus, instead of writing x, we will write ax plus b whole square multiplied by the derivative of ax plus b. Okay, so if you want to open the square, that's not the big of a deal. If you don't want, just don't open it. Ax square b, I won't open it because, you know, I just don't want to get into the mess and waste my time on it. So the derivative of ax plus b is actually a. You know why? Because the derivative of ax would be a. X will be cancelled, and the derivative of b is of course 0 because it is a constant. The a is a constant, it is being multiplied by x, so it won't have, the derivative won't have any effect on a. Okay, so this is the final derivative, and let's just check the second method. Now we will use the chain rule over here. So the derivative would be dy by dx. Of course we have to find dy by dx. So the derivative would be dy divided by d third variable multiplied by d third variable divided by dx. Okay, so we have to take the derivative of y with respect to, of course, the third variable is u, then the derivative of third variable u with respect to x. Okay, so first of all, let's just take the derivative of y with respect to u. Y is equal to, let's just apply the differential on both sides. So we have to take the derivative of y with respect to u, d by du sine hyperbolic inverse u. Now what was the derivative of sine hyperbolic inverse? It was 1 divided by square root of 1 plus x square. So over here we have u, so we will use u square. Okay, and what is the value of u? We just said that u is actually equal to ax plus b. Okay, so we have to take the derivative of u with respect to x. So du by dx is equal to d by dx ax plus b. So the derivative of ax would be, a will be separated because it is a constant, derivative of x will be cancelled, so we are left with 1, and b is a constant, so the derivative of any constant is 0. So the derivative of u with respect to x is a. Now let's just put back the value of u in this term, so we have 1 plus ax plus b whole square. Okay, now let's just put these things into the chain rule. So dy by du, what is the value of dy by du? We have 1 divided by square root of 1 plus ax plus b whole square multiplied by the derivative of u with respect to x. It is a right over here. Okay, so this is the final derivative of this term, and if you're unsure about the chain rule, you can check my videos on it. Okay, so now we have to find the derivative of cos hyperbolic inverse secant x, and yeah, we can also use the chain rule over here and also the traditional method. So first of all, let's use the traditional method. Let's just apply the differentials on both sides of the equation, d by dx. So the derivative of cos hyperbolic inverse x is actually root of square x square minus 1. So this thing right over here is my x. So we have to write 1 divided by, instead of x, we will write secant x whole square minus 1 multiplied by the derivative of the function. What is the function? Secant x. 1 divided by square root of, this would be secant squared x minus 1 multiplied by the derivative of secant x is secant x dot tangent x. And I just wanted to remind you of a property of trigonometry which says that secant square theta minus 1 is actually equal to tangent square theta. So over here, instead of having theta, we are having x. We can just replace this secant x square x minus 1 with tangent square x. Okay, so 1 divided by square root of tangent square x multiplied by secant x or tangent x. Now let's just cancel these squares. So we have left with 1 divided by tangent x multiplied by secant x tangent x, and the tangent x is cancelled, so the final derivative is secant x. Now let's just use the chain rule. So I've just said that this secant x is my third variable, okay, u. So if we rewrite the equation, we will have y is equal to cos hyperbolic inverse secant x will be represented by u. Okay, so according to the chain rule, dy by dx, we have to find dy by dx, dy by d third variable dot d third variable divided by dx. So what is the third variable? It is u. So first of all, you have to differentiate y with respect to u, then you have to differentiate u with respect to x. So y is actually equal to cos hyperbolic inverse u, and let's just apply the differential. D by du is equal to d by du cos hyperbolic inverse u. What is the value of, what is the derivative of cos hyperbolic inverse? It is 1 divided by the variable square minus 1. So 1 divided by, instead of having x, we are having u square minus the derivative of u with respect to x. So u is actually equal to secant x, and if we apply the differential, derivative of u with respect to x, d by dx secant x. So what is the derivative of secant x? It is of course secant x dot tangent x. Now let's just put these things into the chain rule, but before that, let me just write the value of u square. It is, the value of u is actually secant x square minus 1. Now let's just put these values into the chain rule, dy by dx. So the value of dy by du is actually 1 divided by square root of secant square x minus 1 multiplied by du by dx is secant x dot tangent x. Now it is the same situation which we were having in the previous method. So we will have 1 divided by tangent x multiplied by secant x dot tangent x. These things are cancelled out and we are left with secant x. Okay, so this is the final derivative.